Welcome to this explainer. Today, we're taking a seriously fascinating intellectual journey. We are going to explore a rigorous academic overview of statistics, but, and this is important, not the dry, formula-heavy statistics you might remember from a college lecture. No, we're looking at statistics, concepts, and examples through a profoundly philosophical lens. We're setting the stage for a kind of hero's journey today, moving all the way from the illusion and vagueness of our everyday words right into the ultimate objective truth of mathematics.
Here's our roadmap for the journey. We've got 5 key stages to cover. We'll start with the primitive poverty of words, wade through the messy domain of mud and flesh to discover math, confront the curve of no difference, hit the climax of the F ratio, and finally, completely redefine how we think. Let's jump in.
Section 1. The poverty of words. This is where we cross the threshold out of our comfortable everyday reality and step into a really profound philosophical problem.
The ancient Roman poet Lucretius actually had a perfect phrase for this problem, patri sermonis agestas, which translates to the poverty of our native language. You know, natural languages like English or Greek, they evolved to help us survive and socialize, right? They definitely didn't evolve to measure the cosmos. They're just inherently tied to our subjective, messy sensory experiences. Because of this, our everyday words are utterly inadequate for the precise, unambiguous measurement of nature. Think about it for a second. When you try to describe the physical universe, your words are just vague approximations. Language essentially traps us in these qualitative illusions, making it incredibly difficult to capture the true objective essence of reality.
Moving into Section 2, mud, flesh, and math. This is where the core conflict of our explainer really kicks into high gear. So, when we look at how we measure reality, it boils down to 2 totally different worlds. On one side, you've got the mud and flesh domain. This is the empirical world of our everyday senses. It's messy, it's highly variable, and it is constantly shifting. On the exact opposite side, we have the formal domain. This is the world of pure abstractions, perfect logic, and mathematics. The core argument here is that science only truly progresses when we take the perfect immutable models of the formal domain and superimpose them onto the imperfect, messy world of mud and flesh. Honestly, without that formal domain, we are essentially just guessing in the mud.
To actually bridge this huge gap from sensory illusion to mathematical truth, our measurement scales literally have to evolve. We start way down at the nominal scale, basically just categorizing things with words or names, which, as we just learned, completely fails to capture true quantity. Then we have to push past ordinal rankings, which give us an order but absolutely no equal spacing, until we finally reach the interval and ratio scales. These advanced scales give us equal distances and a true zero. They are the exact tools we need to bypass our own subjective human bias and apply the precise calculus required to measure continuous physical phenomena.
Section 3. The curve of no difference. Now that we are equipped with proper measurement, we face our first real trial in the formal domain.
Okay, so to make sense of all this mud and flesh, we desperately need a way to transform raw, chaotic data into a perfect mathematical model. Enter the z-score. It serves as the absolute foundation of the normal distribution. By calculating the mean and measuring the dispersion, or variance, around that mean, we can take any messy empirical data and standardize it into this beautiful symmetrical curve. Suddenly, this mathematical model allows us to see patterns and probabilities that are completely invisible to our naked senses. It's like putting on a pair of X-ray glasses for reality.
But let's be real. Reality rarely hands us infinite, perfectly balanced data sets, does it? Mostly, it just gives us messy, small samples. To handle this, the statistician William Seeley Gossett developed the T-formula, which cleverly adjusts the normal curve for that exact real-world uncertainty. This creates our baseline, what we call the curve of no difference. We then test our messy, real-world data against this T-formula to rigorously, mathematically prove whether our results actually mean something or if they're just random background noise.
And this reveals a pretty beautiful truth. Statistics is actually an evolutionary pyramid of formal concepts. Look at how it all builds on itself. The T-formula is really just a modified z-score. And, as we're going to see next, the F ratio is just a modified T-formula. These aren't just a bunch of disjointed, intimidating equations you have to memorize for a test. They are a continuous logical ascent out of the traps of natural language and directly into the formal logic of the universe.
Which brings us to Section 4, Variance and the F ratio. This is it, the climax of our journey.
We have to ask the ultimate question. Once we strip away the vague illusions of words, and once we know exactly how to reject that curve of no difference,
how do we actually identify true causality in the universe? How do we definitively prove that A actually caused B?
Think about causality like being a master of the waves. Picture yourself sitting by the ocean, just watching the waves gently crash on the shore. The natural, random difference in the height of those waves is your baseline. That's the endogenous variance. Now, imagine someone jumps into the water and claims they can magically create a giant wave. They splash around and a wave hits the shore. So how do we know if they actually caused it or if it was just a naturally larger wave rolling in? Well, we have to compare the treatment variance, the size of the wave after their manipulation, against the natural background variance of the ocean itself.
And that brings us to a radical redefinition of causality itself, the F ratio. It is incredibly simple, actually. It's just the variance between our groups, the actual effect of our treatment, divided by the variance within our groups, which is the natural, messy baseline of the mud and flesh world. If the variance between is significantly larger than the variance within, boom, we have successfully isolated a true effect from the chaotic background noise. Causality isn't a verbal argument anymore. It is a strict mathematical ratio. This logic is so elegant that it actually demystifies one of the most intimidating things you'll ever see in a statistics paper, the ANOVA summary table, and specifically degrees of freedom. Instead of getting totally lost in complex formulas, we just need to know that degrees of freedom is simply n, the number of items, in the basic variance formula. It just represents a very simple component of calculating variance. By focusing on the concept rather than the complex equations, this ultimate tool of empirical validation becomes totally accessible to anyone willing to look past the jargon.
Finally, Section 5, the ultimate modus cogitandi. Let's talk about what all of this means for how we actually think.
This whole framework isn't just some modern mathematical trick. It actually builds directly on ancient philosophy. The pre-Socratic philosopher Parmenides realized a long time ago that the haphazard, sensory-based methods of ordinary mortals, what he called what is not, were completely flawed. Mortals rely on natural language and raw observation, which just leads to endless contradictions. Parmenides argued for a formal, logical method, a what is, that was perfectly abstract and mathematically rigorous. The guy was literally anticipating the scientific method and statistical analysis millennia before they even existed.
Ultimately, what we're looking at here is that statistical methodology isn't just some chore you have to do at the end of an experiment. It is a formal modus cogitandi, a complete, overarching way of thinking. Because our natural language is so flawed and so subjective, this mathematical framework is the absolutely only, truly objective way we have to reveal nature's hidden order. It bypasses all our human illusions and acts as the true language of reality.
So we've gone from the poverty of words all the way to the absolute clarity of the F ratio. But I want to leave you with a pretty provocative thought. If our native languages inherently limit and distort our perception, and if this mud and flesh world is just chaotic variance, are mathematical structures and statistical models the only true reality we can ever genuinely know? Think about that long after this explainer ends. Thanks so much for joining me on this journey.